Okay, now that we have the input taken care of, it's time to start looking at the conditions. And I'm going to just quickly review what's going on here, all right? For example, I have, is b divided by a greater than 0? Is a equal to 0? Is b equal to 0? Well, in your book, it says that if a is equal to 0, we're going to be trying to divide by 0, right? There it is. We're dividing by 0 right there, which means that the program will crash. This is like really important, okay? And if b is equal to 0, the program will proceed, but x1 and x2 will be equal to 0. So this here is a condition to where the program will succeed, but here, this condition is where the program fails miserably, and in truth, this condition here will cause a failure in the program because we're going to be trying to take the square root of a negative number. And any number that is squared will always be positive, so we can't do that. So I think what I'm going to do is I'll come down here and I will do my division by 0 problem first. And basically what we do is we trap it. And how exactly do we trap it? Okay, well, I just happen to have typed this up already, so I'll come down here to processing and I'll just paste it in there. Handy dandy tab key, Command V, and there it is. All right. Here's my comment, if a is equal to 0. That's this condition right here. If a is 0, because that's what the double equal sign means, message, the variable cannot be 0, okay? The variable a cannot be 0. Basically, that's the message, because up here I said, please enter any non-zero number for a. So now I'm going to set a message that's in keeping with my previous message that says, hey, the variable can't be 0, all right? And basically, that's going to be done. The program's going to be done. Well, right now, the program isn't going to be done. It's going to run the test, and then it's going to fall through and continue doing stuff, whatever stuff follows after this, right? So that means that I want to do another condition. I want to say if a is equal to 0, go ahead and send out a message. But if it's not equal to 0, do something else. Well, I want to do several something else's. So what I can do is I can figure out how to do if, else, if, else if, that kind of stuff, right, in Python. So how do we pull that off? Well, once again, we can either go to videos, we can go out to the World Wide Web and look it up, or what have you. For example, I can pop into my browser very, very quickly, and I can say Python, if, else, ELSE, and it comes down here, it says Python if else statement. Hey, that's pretty cool, right? Oh, they even have a shorthand version. I haven't looked at the shorthand version, but for right now, let's look at this one. And it comes back here, if statements, hands-on Python tutorial for Python 3.1. Yay, this is pretty cool. And then we have one down here, Python if, elif, else statements. Hey, this is pretty cool too at tutorial point. So we'll come over here, and it gives me exactly how it's supposed to look, and it even shows me a flow diagram. So you guys, if you can't figure out how to do something in Python, man, go to Google, look it up, because you are without excuse. There is so much material out there to help you program in Python. It even gives you, here's the syntax of the language, and down here it even gives you an example on how to pull it off. Okay, so there it is. There's the if, else if situation. Now what I want to do on my else if is, since I checked a is equal to 0, I'll just go ahead and say if b is equal to 0. That'll make things nice and convenient, right? So come over here and put in if b is equal to 0. That was really unexpected. I have no idea why that happened. My computer just gave me a really weird class message, which it shouldn't have done. So there we go. Make sure that those are lined up, because when we're dealing with if statements, they have to be perfectly lined up, okay? So elif, b is 0, and remember I've got my colon there to make sure that I am correct in terms of syntax. And now I send out a message, both x1 and x2 are 0. So I look at a to see if it's 0, and if it's not, it's going to do the else. So I'll come down here, it's going to check if b is equal to 0, right? So it does that. Now that I've handled that one, I can just come over, grab my little snippet of code that I've already written to speed up the lecture, and I'll paste it in. Now I'm going to handle my last condition. Remember, there's my last condition. B divided by A is greater than 0. And here it is. If B divided by A is greater than 0. So now I check for A equal to 0, B equal to 0, and then B divided by A is greater than 0. So I have checked all the conditions that were mentioned in the book. Now you'll notice that I didn't do anything in terms of trying to figure out this equation. I just simply implemented what the book gave me, nothing more. So don't try to sit down here and beat yourself up coming up with some great mathematical algorithm that's going to solve all of this stuff, okay? This is pretty straightforward, pretty easy. Just follow the stuff that's given to you in the book. So now that I'm checking it, A equals 0, B equals 0, B divided by A is greater than 0, I've got to do the actual work. And the actual work is going to be to run the calculations. So we'll go ahead and backspace here, and now I get to type in else. And what I'm going to do again is I'm going to grab a hold of a little snippet of code here, and I'm going to demonstrate the principle of top-down programming, okay? And that principle is, as I said, x1 is going to be get x1 and x2 is going to be get x2. Is there an x1 or a get x1 anywhere? Not in Python. Is there a get x2 anywhere? Nope, there's nothing of the sort in Python. It means that when I'm doing something like this, that I am expecting to program my own little function, program my own little module, okay? So that's what I do. I create some comments. And I pop in my module, and the module says this function or module returns x1. I have parameter A. I don't know what A is, so I can't tell you exactly the units or anything, so I just say parameter A, parameter B, because those are the inputs or the arguments, all right, and that it returns x1. And I made life easy on myself. I didn't store this in a temporary variable. All I did was I returned negative B divided by A, and 2 asterisks in Python is the same thing as doing square. And in mathematics, if you square something by 1 over 2, you are taking the square root. If you want to take a cube root, then what you do is you square something by 1 over 3. Okay? So, or take it to a power. Here, or not square something by 1 over 3, but take it to a power of 1 over 3. So this here is taking negative B over A to the 0.5 power. Okay? Now as we look at this equation, we can see where there could be a potential problem. For example, if B is positive, right? Well, here's A, here's B. B will come in positive, but then this minus sign is going to make it negative. I'm going to have a negative B then, or like if B is 2, I would have a negative 2, and if A is 2, divided by 2, right? So now this becomes negative 1, and you can't take the square root of negative number. It will crash. This is why we have this condition right here. It makes sure that it has a real solution, because you see, if something fails due to a negative square root, we say that it has no real solutions. Somebody might say, well, why not just say it's not going to work? Well, because sometimes we want to take the square root of a negative number, because in certain conditions having to do with energy calculations, that negative square root is very, very important to us. So what we'll do is, before we take the square root, we'll just make it positive, and we'll remember the fact that the square root was negative, and we'll send out a message that this is an imaginary number. It's not a real number, it's an imaginary number. And here's the answer to the imaginary number. For those of you who didn't get it, don't worry about it. It's not that big of a deal at this point in your life, but following the book's paradigms that they gave us, you know, the instructions, it ended up saving us in this particular area because of this statement right here. There is never a situation where this value here will ever end up being a negative value. We will never be able to take a negative square root, because this if condition right here prevents it from happening. That's why it's above all of this. That's why these things are all before the actual work, because they're going through and they're testing all the conditions that we can address before we actually do the work. Conditions that could cause failure, or conditions that say there's really no point in even doing the work, such as b being equal to 0. If b is equal to 0 and it's divided by a, what's the result going to be? 0. So why bother running the calculation, right? We can intuitively see that. So here we are. We've got this taken care of. I wrote the x1 module, okay? And now I get to write the x2 module. In your book, you'll notice that the formula for x1 and x2 are exactly the same with one tiny little difference. And that is x2 is simply the negative value of x1. So I just go ahead and I create another module whose sole goal is to call x1, run the calculation, and then change its sign. So here it is, return, there's the minus sign right there, and then I have get x1. So now, if I haven't made any big blunders in all of this, I should just about be ready for output, except that I don't have any output, right? So what's the next step? Well, the next step is, by the way, if A is, yeah, we've already did the messages. The next step here is, of course, to create the message for the circumstance where x1 and x2 can be calculated. And the way that I did that was I just used our standard formatting that we've tinkered around with already in the class, okay? And the way that I do that is exactly like this. Tab in, message is equal to x1 equals %0.4f. That is a floating point placeholder that'll do to 4 significant digits if necessary. And x2 is equal to %0.4 float, okay? And then down here I want to pass these values that are calculated into this sentence, right? This is going to hold this piece of information, and this will hold this piece of information, okay? All right, messages are all created. Now all I have to do is print the message. So I'll come down here to the output and pop in our handy dandy message, and then we get to run our test cases. How do we run our test cases? Pretty easy, right? Got 12-13 minutes. Can I run the test cases in 2 minutes? My time is limited to 15. So this is 13 here. I should be able to pull it off. How do we do it? First of all, we save, we run the module, give the input. I'm going to go a equals 0. That's one of the conditions, right? B I don't care about. I'll just say 4. And it comes back and it says the variable cannot be 0. See? It came through here. This condition was satisfied. It printed that, and it totally skipped the rest of it. All right? So now let's run the module. And this time I'm going to make a equals 2, and I'm going to make b equal to 0. And again, this condition wasn't satisfied, but it did look at this, and this was satisfied, so it says both x1 and x2 are 0. There you are. See, that's working out pretty good. Run the module again, and this time I'm going to say a is 2, and b is 2, like so. Or I'll just say b is 4. Actually, I'll go 2 for now. And it's going to come back and say there are no real solutions, and that's this condition right here, because 2 divided by 2 is 1, and is 1 greater than 0? Absolutely. There are no real solutions. And then finally, we have the solution, okay? And what I'm going to do is run the module again, and this time I'm going to use, say, a will be a -2, and b is going to be 4. And we'll hit that, and it comes back and it says that x1 is 1.4142 and x2 is -1.4142. And there you have it. The whole critter works. Remember, the key is begin with what you know, comment it all out here at the top, and then build the module from the top down. Okay? We started with the main. We ended up ultimately doing all of our test conditions to make sure that we would get through all of the things that could hang us up. And then we finally came down here and created two modules that would actually run our calculations for us. And by creating those modules, it made it a little bit easier code-wise to get through this whole project. Hopefully that helps you to understand this program assignment after the fact. With that, I guess I will say happy coding.